Today we are going to cover the fundamental counting principle, factorials, NPR permutations, and NCR combinations. First, the fundamental counting principle. The fundamental counting principle says, if one event can happen in M ways and another event can happen in N ways, both events can happen in M times N ways. Blah, blah, blah. So let's look at number one. If you went to a restaurant with the menu listed above, how many ways could you order an appetizer and a drink? So think about it. If you order stuffed mushrooms, you could then order a Coke or a Sprite or a Dr. Pepper or an iced tea. So if you order stuffed mushrooms, there's 4 options. Stuffed mushrooms and Coke, stuffed mushrooms and Sprite, stuffed mushrooms and Dr. Pepper, stuffed mushrooms and iced tea. 4 options. If you order nachos, you also have 4 options. Nachos and Coke, nachos and Sprite, nachos and Dr. Pepper, nachos and iced tea. And then mozzarella sticks, that's another 4. So how many ways is that total? 12. And the quick way to get that is, I like to think of the fundamental counting principle as the blanks principle. This blank represents the number of appetizer choices. This blank represents the number of drink options. There are 3 appetizer choices. There are 4 drink choices. Multiply them together. There are 12 ways that you can order an appetizer and a drink. How about a drink and a dessert? A drink and a dessert. 20 ways. We've got 4 drinks. We've got 5 desserts. That is 20 ways that you can order a drink and a dessert. So on your own, I would like to know how many ways can you order an appetizer, drink, entree, and dessert? All right, 3 appetizers, 4 drinks, 3 entrees, 5 desserts. Altogether, that is 180 ways that you can order all of those things. Now, if I asked you to list all of them, that'd be really fun. Do you guys want to do that? It'd be fun. That'd be really fun. Okay. Next is license plates. You can also use the fundamental counting principle to figure out license plates. And this is something that like some math person in the DMV actually does. If you have a state that has a huge population, you need to have enough license plates for the potential number of vehicles that you're going to have. So they do use this kind of math to figure out how should they configure their license plates. So the standard configuration for a New York license plate is 3 digits followed by 3 letters. So I'm going to use blank, blank, blank for the 3 digits. So these 3 are going to be digits. And then blank, 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 these 3 are going to be letters. The digits are 0 through 9. How many digits are there, 0 through 9? 10 digits. There's 1 through 9 and 0. So we have 10 possible digits that could be the first part of the license plate. 10 possible for the second, 10 possible for the third. How many letter choices do we have? 26. So 26 possible letters for the first, 26, 26. This is going to be a big number. So the license plate 000AAA is one possibility. The license plate 111BBB is also a possibility. This is including repetition. So plug this into your calculator. 17,576,000 possible license plates. Next, we're going to talk about what if the license plate digits and letters cannot be repeated. So I'm still going to do blanks. And these first 3 are my digits. And the last 3 are my letters. So I have 10 possible digits for that first part of the license plate. So I have 10 options for this first blank. Next, if we use one of those numbers and stick it in the license plate, we now can't use that number anymore. How many numbers do we have left that could be in the second part of the license plate? 9, and then 8. So because we are not allowing repetition, the number is going to decrease because as we use the number, we can't use that number anymore. So now there's only 9 unused options, and then there's 8 unused options. So for the letters, our first letter, we have 26 unused letters, and then we have 25, and then we have 24. So now plug that into your calculator and see how many possible license plates there are if repetition is not allowed. The concept of non-repetition leads us directly into factorials. N factorial is n exclamation point. An exclamation point in math is a mathematical symbol that means take that number times the number 1 less, times the number 1 less, times the number 1 less until you get to 1. So for factorial, for exclamation point, it's not saying 4. It's saying 4 factorial. 4 times 3 times 2 times 1. So it's not exclaiming 4. It's not the same as an exclamation point in English. It is a factorial. So 6 factorial would be 6 times 5 times 4 times 3 times 2 times 1. Plug that into your calculator and see what 6 factorial is. Wouldn't it be nice if you had the factorial function in your calculator? Guess what you do? If you have a scientific calculator, you're going to look in the PRB button. So if you have the normal scientific calculator that most of you have, there's a PRB button that's kind of at the top. It's like diagonal from the second button. So you're going to enter 6 first, and then PRB, and then look at your options, and you've got the exclamation point. Do 6 exclamation point, 6 factorial, you should get 720. In the graphing calculators, when in doubt, check the math button. So I'm going to enter 6, and then push my math button. Do you notice over on the right side of the screen it says PRB? You can either arrow right or arrow left to go over to the PRB menu. And then notice the 4th option down is the exclamation point, the factorial. 6 factorial is 720. So find the factorial feature on your calculator, and on your own, please find 10 factorial. It's 3,628,800. Okay, and factorials lead us directly into permutations because permutations use a portion of a factorial. Permutations are kind of like what we did in the license plates with no repetition. A permutation is an arrangement of objects in which order is important. And here's the thing I want you to remember. You should circle the word permutations and circle put in order. I want you to start associating that P in permutations with put in order. With a permutation, you're putting something in order. Here's an example of a permutation. Let's say there's 20 of you in this class. We are going to elect president, vice president, and secretary. If I elect Shiv as president, that would be different than me selecting Xavier as president. So the order that we select people for president, vice president, and secretary, the order matters because whether we select student A for president or student B for president, it's different. In math, using that, we would do 20 students P3. This is called NPR. 20 P3. 20 would be the total number of things that you have. 3 is the number that you want to put in order. So I want you to associate that P with put in order. You've got 20 things, put 3 of them in order. There is a fancy formula for it. We aren't going to do the fancy formula because your calculator can do it. So 20P3. In the scientific calculators, you'd punch in 20, push your PRB button, select NPR, and then punch in the 3. In the graphing calculators, 20, math button, go over to your PRB menu and find your NPR, and then hit enter. If we had 20 students and we were arranging 3 of them into positions like president, vice president, secretary, there would be 6,840 ways to do that. Now the question it's asking you in your notes, how many ways can you order the two of the letters from A, B, and C? So we have A, B, and C. We want to arrange them 2 at a time. We have 3 total things. We are going to arrange 2 of them. 3 things, put 2 of them in order. So try in your calculator 3P2. We're selecting 2 letters from A, B, and C. So we have 3 things total. We are putting 2 of them in order. And you should have gotten 6. Now let's think about what that would be. AB or BA, AC or CA, and BC or CB. Those are these 6 ways that you can arrange 2 of those 3 letters. Okay, so we already looked at how to do that on our calculator. On your own, on your calculator, please find 5P3, 8P3, and 5P1. Now, 5P3, you don't really need to use NPR for this. 5P3 means that you have 5 things, and you want to arrange 3 of them. So you've got 5 times 4 times 3. NPR just allows you to not have to think about the blanks and not have to think about the numbers to put in those blanks. So it's really the same as the fundamental counting principle. It just kind of condenses it a little bit and allows you to do it more quickly. Combinations are kind of the same thing. We have NCR. When you were doing this in your calculator, you may have noticed NCR right with the NPR. A combination is when you are choosing something and the order doesn't matter. So I want you to think of combination, C, as choosing something. So let's say out of 20 students, I'm going to choose 3 students for an all expenses paid trip to Jamaica. Does it matter if I choose Shiv first or if I choose Xavier first? They're both going to Jamaica. So the order doesn't matter. I'm just picking 3 students to go to Jamaica. I'm actually not, because I'm not made of money. So if you turn to the next page, how many combinations of the 2 letters of A, B, and C are there? We have 3 total things. We are going to choose 2 of them. So try to figure out in your calculator how to do 3C2. If you have a scientific calculator, it's the same way that you did NPR. You just select NCR instead. In the graphing calculator, oops, I'm not doing 20, I'm doing 3, math button, go over to your probability, choose NCR, punch in 2. There are 3 ways. And if you think about this, you can choose A and B, you can choose B and C, or you can choose A and C. The order of the letters doesn't matter. I'm just picking A and B, or I'm picking B and C, or I'm picking A and C. There's 3 ways to do that. So on your own, please try to do 5C3, 8C3, and 5C1. Okay, so an example of 5C3. You've got 5 things. Let's say you've got 5 books, and you're going to pick 3 of them to take on vacation with you. Doesn't matter what order you select the books. You're just going to grab 3 books out of the 5 and take them on vacation with you. 8C3. 8 students, 3 are going to be selected to represent our class on a committee. There's no specific title. It's just we're going to pick 3 students out of the 8 to go represent the class. Those are examples of choosing where order does not matter.